is the third question of the June 2011 paper 6 variant 2 statistics. Now the third question is slightly tricky. It says a sample of 36 data values values of x gave sigma of x minus 45 a value of minus 148 and sigma x minus 45 squared equal to 3089. Now, just remember one point in this. Sigma, my mouse is gone, sigma of x minus 45, the whole squared, is not equal to sigma x minus 45 squared. So you cannot take this value squared and expect to get this value. That's a key point in this. Now let me make this full screen. So now we have to find, now the first question is we have to find the mean and standard deviation of these 36 values. Now there are a few formulas in this to remember, and one of them is this: sigma of x minus a divided by n plus a is equal to x bar or mu. Now x bar and mu are denotions for mean, and a in this case is 45. So a is 45. N is the number of data values. In this case, it's 36. So this is so finding the mean is easy with this formula. All you have to do is just sigma of x minus 45 divided by 36 plus 45 is equal to your mu or x bar. X bar is another denotion of mean. So minus 148 divided by 36 plus 45 is equal to, now if you do this, it's just equal to 45, 40.8, or we'll just round that up to 40.9. It's 40.88, so it's 40.9. Let me find my mouse now. Yep, I found it. 40.9. And this is our mean. Now I'm going to write the mean down over here, and I'll write it as x bar, because that's a denotion here. In normal distribution, the denotion is a mu. It's kind of confusing, but you can get used to it. So 40.9. Now standard deviation also has a nice formula. I hope you've taken this down. Just clear this page. The standard deviation formula is slightly more complicated. It's just x minus a squared, it's just this squared, divided by n minus x minus a sigma divided by n. This whole thing, you root this. Oh, and you have to do this whole thing squared. Now this is equal to your sigma or your standard deviation. Now what you have to do is, now using this formula you can find the standard deviation. That is, in this case it would be x minus a the whole square is just 3089 divided by 36 minus sigma x minus a minus 148 divided by 36 the whole squared. And solving this, you would get 3089 divided by 36 minus 148 divided by 36 the whole squared, and you would get 8.3, and you have to do the root of that. So you would get 8.3, and this is equal to your standard deviation. So let me just write this. This is standard deviation 8.3. Now I'm going to clear this page and I'll move on to the next part. I hope you understood that. Those two formulas are very important. At the end of the lecture, I'll write down those two formulas so that you could take that down. Now moving to the next part, one extra data value of 29 was added to the sample. Find the standard deviation of the 37 values. Now, this is very important. Now, you have to remember something. The mean formula that we were discussing earlier, that is sigma of x minus 45 divided by n plus 45, you can call this a or 45, it doesn't matter, is equal to x bar. Now, x bar is also equal to sigma of x divided by the number of values n. Now, this is also a very important formula. Sigma of x is just the sum of all your data values divided by the number of data values, n. In this case, your number of data values has increased from 36 to 37. So, now we want to find sigma x. So, sigma x is just the mean that we got before, that is 40.9, into the number of data values, 36. It was originally 36. Now we want to find the sum when we used only 36 data values, not including the 29. So that's what we want to find the sum of first. So 40.9 into 36 is equal to 1472.4. Now the reason we're doing all this is we want to find the mean, the new mean, when this new data value of 29 was added to this to the experimental samples. So now that we've got sigma x, we can find the new sigma x, that is the new sum of all the data values, by doing 1472.4 plus our new value 29, and this is equal to 1472.4 plus 29, and you get 1501.4. Now, we still need this page, so I hope you got this. I'll just write down the values that I need in this. We need 1501.4. This is an important value. We don't need 1472. This was just to find our new sigma x. This is our new sigma x. Very important to find the standard deviation. So I'll clear the screen in this case. Now we want to find the new mean. So the new mean is just the new sigma x divided by the number of data values, 37. Now we've added that 29, so there's one more data value. So if we find the new mean, we get 40.6. Now we can keep this on the side. Now it's very important to note that originally when we found the old sigma, that is this sigma, we used the formula sigma of x minus 45 squared, only this squared, divided by 36 minus sigma of x minus 45 divided by 36, the whole squared, and we found that we found the sigma, the root of this. This is root. Now we know that sigma is also equal to, now this formula is also very important, is also equal to root of sigma x squared, only x squared, sigma x squared, divided by 36 minus sigma x divided by 36, the whole squared. This sigma is equal to this formula and this formula. Now remember, as I said earlier, sigma x is not equal to sigma x squared. This sigma x the whole squared is not equal to this sigma x squared. So keep that in mind. So now that we've got these two formulas, we can use this second formula that we have over here to find sigma x squared, which is very important in finding our new standard deviation. So let me clear the screen in this case. So now let me write down our formula again. We have sigma is equal to root of sigma x squared divided by n minus sigma x divided by n, the whole squared, And now we found sigma x originally as 1501. This is our new sigma x. Our old sigma x was 1501.4 minus 29, because we added that 29 later in the story. Now our old sigma x was 29. Now we're trying to find our sigma x squared, our old sigma x squared in this case. So we have to use our old values. That is our old sigma x, our old n is 36, our old sigma x is 1472. And our sigma is 8.3. That's our old sigma. So this is root of sigma x squared divided by 36 minus sigma x is 1472 divided by 36, the whole squared. Now we square both sides and we get 8.3 squared, which is just 68.9, is equal to sigma x squared divided by 36 minus, let me find the value of that second part, 1472 divided by 36 squared, and we get 1671.9. And now finding sigma x squared, making it the subject of the formula, we have 1671 plus 68.9, and this into 36 is equal to 62668. I hope you see how I got that there, 62668. And now that we found our old sigma x squared, we can find our new sigma x squared by adding in our new value. Now, you remember that our new value is 29. So, to do this, we add our new value by doing plus 29 squared, because it's all the x squared. So, our new x value is 29, and we have to square it and then add it to our sigma x squared. So this plus 29 squared gives us 63509. I'll clear this page again. I'll take down the value first. So our new sigma x squared is equal to 63509.8. And this is a very important value in calculating our new sigma. So I'll clear the page here. Now our new sigma is equal to the same formula that we had before, our new sigma x squared divided by our new n minus our new sigma x divided by our new n, the whole squared. So then now we want to do root of our new sigma x squared is just 63509.8 divided by our new n is 37, because we've added a new value from 36 to 37. And our new sigma x, we have had it over here ever since. Our new sigma x is 1501. This is our new sigma x because we took our old sigma x and added the new data value, 29, to it. Now this 1509 divided by 37, our new n, the whole squared. And this should be equal to our new mean. So this divided by 37 minus 1501 divided by 37, the whole squared, root of our answer will give us 8.41. And this should be your new standard deviation value. Our new sigma, or our new standard deviation value. I hope you see how I got that there. Now this problem can be a little bit confusing as to distinguish new from old. Now let me review. I'll clear this page. I'll just list all the formulas that we have discussed in this, because this is the hardest topic in statistics in terms of formulas. So let me clear this page too. Now the first formula you have to remember is sigma of x minus a divided by n plus a is equal to our x bar. Now this is to find x bar. X bar is also equal to sigma x divided by n. Now this is for finding mean. X bar is just mean or mu or anything. Now to find standard deviation, I'll just do this. Sigma is equal to, I hope you can see that there, sigma of x minus a divided by n minus sigma, this is sigma of x minus a squared divided by n minus sigma of x minus a divided by n the whole squared, and this is equal to our sigma. Now sigma is also equal to sigma x squared divided by n minus sigma of x minus a, sigma of x divided by n the whole squared. Now these formulas are very important. It's also about distinguishing between the new and the old in this problem. Originally, in the problem, what we did was we found an old value of mean, we found a new value of mean because of a new data value that has been added to the set. So don't get confused with that. Do a lot of practice in these kind of problems and you'll get a hang of the formulas. I hope you understood this lecture. If you have any questions, please email me.